I'm going to walk through several of the questions that you had from the week before the test that you brought up. One of the things that came out of the survey was there's so many procedures to know, and it's hard to be able to figure out which thing I'm supposed to do. Well, you can ask yourself 3 questions. And if you get the right answer to these 3 questions, you should be able to identify which procedure you're dealing with. So the first question is this a test or is this an interval? That would be the first question. Tests answer yes or no questions. So if the first word is do or maybe are these means different, or are these percentages different, or do you have enough evidence to conclude something? Any yes or no question will be answered with a test, because a test, remember, ends up with either rejecting or not rejecting some null hypothesis. If there's some sort of wording like how much, or if it says estimate, then it's probably going to be an interval, because an interval ends up with 2 boundaries, a lower boundary and an upper boundary, and you believe, you're pretty confident that in between there is something. So if you're estimating how big something is or how different something is, that's a clue that it's an interval. So that right there cuts your choices in half, because half the things we learned were tests and half the things we learned were intervals. So if you can answer that correctly, then you are on your way. The second question that you might ask yourself then, is this a problem about means, or is this a problem about percents, proportions, percents? If it's means, then you're doing a T procedure. If it's percents, you're doing some sort of a Z procedure. That also will narrow it down to now only a handful of options. And then the last question would be, is this 2 independent samples, or is it 2 treatment groups, or is it just 1? And that should give you your final answer. Now, what you have to do, watch out for, is the matched pairs. Sometimes you have 2 sets of data, at least that's what it looks like, but when you read how they collected the data, you realize they were paired up in some important way. And so what might look like 2 samples or 2 treatment groups is actually 1 group of differences, and you would do like a t-test on the differences. And it's really just 1 sample of data or 1 group of data. The data are all the differences in all the pairs, and you just do a t-test on the differences. So that would be one minor caveat you have to watch out for on that last decision. Second question you had were conditions. Conditions are just, there's so many conditions, and some are the same and some are different. And I think if you think about this, and just there's really 2 types of conditions. One type of condition deals with independence. Independence. There are 2 things that will help guarantee independence. First of all, if you have a random sample, when you randomly select things, there's a much better chance that they are independent of each other. Or if it's an experiment, make sure that the treatments are randomly assigned. Again, if the treatments are randomly assigned, then that helps independence between individuals. The second thing that helps guarantee independence is that the sample size is less than 10% of the population. Now, this is only for samples. You don't do this for experiments. If it's a sample or 2 samples, you have to check that both of them, or the one, is less than 10% of the population. But that's only for samples. You do not check that for experiments. And then sometimes there's a third one, and that would be independence of the 2 groups. If you have 2 samples or 2 treatment groups, you have to make some sort of a statement of assumption or declare that it's reasonable to believe that the 2 groups are independent of each other, because there's a standard deviation formula that involves adding variances, and you can't add variances unless the groups are independent. So sometimes you have to check independence of groups. So that is the first major thing to check. The second major thing to check is to make sure that your sample size is big enough. So sometimes this is called the large counts condition. The large counts condition. or it's really a check for normality of the sampling distribution. If you have a big enough count, then you can assume a normal sampling distribution or approximately normal sampling distribution. So the second major thing you have to check is that your counts are big enough, or your sample sizes or your treatment groups are big enough. So again, we've got kind of two things. If it's a proportion problem, then you check like n times p is greater than 10, and you check that n times 1 minus p is greater than 10. And of course, if it's a confidence interval, then you got to use p hat instead of p, but it all depends on whether you're doing a test or an interval. If you're doing a test, you can use p. If you're doing an interval, you have to use p hat because you don't have p. The second large counts condition is for mean problems, and for mean problems, you just have to make sure n is greater than or equal to 30. But of course, sometimes n is not greater than or equal to 30. If not, you must graph and comment on what you get. So even if you just have, a small sample that's not very big, but it looks like this, and there's no outliers or heavy skewness, well, then we can proceed, even if you don't have a large enough sample size. So large counts condition and independence, those are really kind of the two main categories of conditions. And if you can remember those, then maybe that'll get you down the road enough that you can remember how many conditions total you have to have. So there's item number 2. The third thing that you had a question about was type 1 and type 2 errors. Here's how I remembered it. I remembered that type 1 is rejecting. Type 1 is reject. Now remember, this is an error. This is an error in a conclusion. It's the wrong conclusion. And I kind of don't really like the word error, but that's what we're stuck with. It's really not a mistake in the sense that, oh, I did something wrong. It's just that your sample happened to be weird, and because it was weird, you concluded something that was really not true, turns out. So it's really not a mistake of procedure. It's not a mistake of doing something wrong in the analysis or the calculations. It's just you got a weird sample. That happens every once in a while. So type 1 is rejecting, and because it's the wrong conclusion, usually you can figure it out. It's rejecting when you shouldn't. In other words, it's rejecting when actually the null was true to begin with. So if you want to finish that out, it would be a type 1 error is rejecting a true null hypothesis. That would be a mistake, to reject a true null hypothesis. And then I just remember that type 2 is the opposite. So if you can nail type 1 really well, and you know that inside and out, well then type 2 is just going to be the exact opposite. Type 2 is not rejecting a false null. So that should be easy if you can memorize one of them really well. The other one is just the opposite. And then the only other thing, the probability of a type 2 error, just in a little tidbit here, is equal to 1 minus power. So they are what we call complementary probabilities. The probability of a type 2 error and power have to add up to 1. So you can always find the value of one from the other. And then one more thing I'll just mention, there are formulas that might be really helpful, and it would be good for you to know those before you get to the test because you don't want to go looking for them when you're in the middle of the test. One formula is for confidence intervals. They have the general formula printed on your formula sheet for confidence intervals. Now that's not going to give you all the specifics, but it's going to help you get started. A confidence interval always starts with some statistic plus or minus some critical value times the standard error of the statistic. Now, the standard error, those formulas are also on your formula sheet. So you can look up the standard error formula for any statistic that you're dealing with. And so you just have to realize that. You can look those up. The second formula that might be helpful is what they call the standardized test statistic. A lot of times these are asked on a multiple choice question. A standardized test statistic can be found by taking the statistic minus the parameter over the standard error of the statistic. That would be how you calculate a t-test statistic. It's also how you calculate a z-test statistic. You take the statistic that you're dealing with minus the parameter that you're assuming is true divided by the standard error of that statistic. And again, the standard error formula for every statistic that we cover in here is on the formula sheet as well. So there are a lot of formulas that you can kind of piece and pull together to answer questions on a multiple choice problem where they have all these formulas that all look alike. These should help you be able to tell the difference between them. So there you go. That's my quick 10-minute flurry of helpful hints to get ready for the Chapter 9-10 test.